In this video, we will learn how to find out the marginal utility of money from the given utility function and price of the two goods and the income of the consumer. The question is, given utility function is u is equal to x plus 2 times y plus 1, where x and y are the two goods consumed by the consumer. Px is the price of good x, which is 4, price of good y is 6, income of the consumer is $130. We need to find out the marginal utility of money. Options are being given. We need to find out the correct option. Okay, so let us write the given utility function. So u is equal to x plus 2 times y plus 1. Let me first simplify this. So we have x plus 2 times y plus 1. Okay, so let us first write x and multiply it by y plus 1. Then we write 2 and multiply it with y plus 1. Okay, so it becomes xy plus x. Then we get 2y plus 2. So we will get xy plus x plus 2y plus 2. Okay, this is our utility function, that is xy plus x plus 2y plus 2. Okay, simply I have simplified it a little bit. So given this utility function, what is the budget constraint of the consumer? So budget of the consumer is, that is the price of good x times units of good x that the consumer will consume, plus price of good y times the units of y that the consumer should consume, should be equal to the income of the consumer. Okay, so what exactly happens here? First we need to find out the optimal consumption bundle of the consumer. Okay, we have to apply the Lagrange's method here to find out the marginal utility of money. So the endeavor of the consumer is to maximize the utility. Let me write it here. Consumer wants to maximize utility subject to this budget constraint. And let us write the given this budget constraint into the specific form, that is we are being given the value of price of x is 4. So again I write it like this: 4 times x plus price of y is 6. So 6 times y should be equal to the income of the consumer, which is 130. Okay, now we apply the Lagrange's method. And let me write it here. We apply the Lagrange method. Okay, method. So to apply the Lagrange method, what we METHOD. Okay, I hope I am doing justice with the spelling. Now to solve this question using Lagrange's method, first what we need to do, we need to rewrite the given budget constraint. Okay, we set this equal to 0, which implies 130 minus 4x minus 6y is equal to 0. Okay, so I have to form the Lagrange's function. For that I need to set the budget constraint equal to 0. That is the first step. Second step is to multiply this new budget constraint by lambda. Okay, after that I can form the Lagrange function, which will be equal to our utility function, which is xy plus x plus 2y plus 2. To this I add the resulting budget constraint, which I formed by setting first this budget constraint equal to 0 and multiplying it with by the lambda. Okay, so we have lambda times, I'm not specific with the colors this time, so we have 130 minus 4x minus 6y. Okay, this is our Lagrange's function. As I told you, to find out the marginal utility of money, we need to find out the optimal consumption bundle. To find out the optimal consumption bundle, we need to apply the Lagrange's method. To apply the Lagrange's method, first what we need to do, we need to set the budget constraint equal to 0, multiplied by lambda, and form the Lagrange's equation, which will be the aggregate of the given utility function, what we also call the objective function, and the resulting constraint. Okay, now to find out the optimal bundle, to find out the optimal value of x, y and lambda, we partially differentiate the Lagrange's function with respect to x, y and lambda and set them equal to 0 simultaneously. Okay, so we take the partial derivative of this function first with respect to x. Okay, so derivative of x is 1, we are left with y, plus the derivative of x will be 1, derivative of 2y is 0 because we are taking partials with respect to x. Okay, here the derivative of x will be equal to 1, so we are left with minus 4 lambda. So let me write it here, minus 4 lambda, and we set it equal to 0. Similarly, we need to find out L y, that means the partial derivative of the Lagrange function with respect to y. Derivative of y is 1, we are left with x, plus derivative of x is 0 because we are taking the partials with respect to y. Derivative of y is 1, so we are left with 2, and derivative of y in the last term will be equal to 1, so we are left with minus 6 times lambda, and we set it equal to 0. Similarly, we need to take another constraint, that is L of lambda. We need to partially differentiate this function with respect to lambda. Since no lambda is involved in the first 4 terms, its derivative is 0. Derivative of lambda is 1, so we are left with 130 minus 4x minus 6y, and we set it equal to 0. Okay, to find out the optimal values of x, y and lambda, we take the partials with respect to x, y and lambda, set them equal to 0 simultaneously and solve them. Okay, so L subscript y means the partial derivative of this function with respect to x. So let us further simplify it. So can we write y plus 1 is equal to 4 times lambda if I transpose this here. Similarly, here what we will get, x plus 2 is equal to 6 lambda. Let us say this is equation 1, this is equation 2nd, and let us say this is equation 3rd. Now what will we do? We divide equation 1 by equation 2nd. So dividing equation 1 by equation 2nd, which implies, so we have these two equations here. Dividing LHS by LHS, so we have y plus 1 upon x plus 2 is equal to 4 lambda upon 6 lambda. Lambda gets cancelled, so we get 2 2s are 4, 2 3s are 6, which implies y plus 1 divided by x plus 2 is equal to 2 upon 3. Cross multiplying, that means 3 times y plus 1 is equal to 2 times x plus 2. Solving further, we get 3y plus 1, 3y plus, rather 3 1s are 3, is equal to 2x plus 4. We need to solve this. So for y, so 3y will be equal to 2x plus 4. Transposing this 3 here, it gets subtracted, so we will get, which implies 3y is equal to 2x plus 3. 4 minus 1 is 3. Dividing both sides by 3, so y will be equal to 2x upon 3 plus 3 upon 3 is 1. Now we need to plug the value of y is equal to this stuff into equation 3rd. Okay, so let's plug the value of y here. So we have 130 minus 4x minus 6 times the value of y is 2x upon 3 plus 1, which is equal to 0. Or we can do one thing also to save the time. We can also plug the value of y in the given budget constraint in this equation. Okay, so it will get lengthy here. So let us plug the value of y is equal to, in the given budget constraint, that is 4x plus 6 times the value of y is 2x upon 3 plus 1, which is equal to 130, which implies 4x plus, here we will get 6 2s are 12x upon 3 plus 6 is equal to 130, which implies 4 3s are 12, so we will get here 12x plus 12x is 24x, so 24x upon 3 is equal to 130, minus 6, transposing this, it gets subtracted, which implies 24 upon 3 means 8x. So 8x is equal to 130 minus 6 comes out to be 124. Dividing both sides by x, sorry, by 8, we will get x is equal to 124 divided by 8, which is 8 ones are 8, 9 ka 4. Okay, so let me see if I have done it correctly or not. Okay, here 6 2s are 12, 6 1s are 6, 3 4s are 12, but 2, 24x upon 3 is equal to 130 minus 6, which comes out to be 124. Okay, so 124 divided by 8, so 8 1s are 8, so it is not divisible by 8. So let's divide it by 4, so we get 4 3s are 12, 4 1s are 4, here we get 4 2s are 8, so 31 upon 2, that will be the optimal consumption of good x. To find out the optimal consumption of good y, plug x is equal to this stuff into this function. I hope I am doing the calculation right, I am not sure. So y will be equal to 2 times the value of x is 31 upon 2 whole divided by 3 plus 1, which will be equal to 2 gets cancelled, we are left with 31 upon 3 plus 1, which is equal to 31 plus 3 is 34 upon 3. 34 upon 3 will be the consumption of good y. Now we need to find out the value of lambda. That will be our marginal utility of money. Okay, so the value of the lambda gives us the marginal utility of money. So to find out the value of lambda, plug the value of x and y. Okay, let us plug the value of y or x in either of the equations 1 or 2nd. Okay, now let's plug the value of y here. So what will we get? We get in place of y we have 34 upon 3 plus 1 is equal to 4 lambda. Okay, so this becomes 34 plus 3, it becomes okay, let me see if I have done it correctly or not. Correctly, 34 upon 3, so we have 34 upon this becomes 34, 35, 36, 37, 37 upon 3. Okay, so 37 upon 3 is equal to 4 lambda, or lambda will be equal to 37 divided by 4, 4 3s are 12, so it comes out to be 3 point something. Okay, that means the marginal utility of money will be equal to, so we have 37 upon 2, 37 upon 12, so this is 12 3s are 36. Okay, 12 3s are 36, 1 is left, it becomes 17, so 12 ones are 12, so we will get 3.1 is the marginal utility of money. That means option C is correct. Okay, let me be very clear, I am not sure about the calculation, but this is how do we find out the marginal utility of money. When we find or when we have what I can say, when we found out the value of optimal input, rather optimal consumption bundle, we need to plug the values of x or y either in equation 1 or equation 2nd to find out the value of lambda, which gives us the marginal utility of money. Okay, when we solved it here, we got the value of lambda is equal to 3.1. Okay, so the correct option should be C option. By marginal utility of money, what we mean here, so the value of lambda is actually what we call the shadow price. Also, it is shadow price, or in this scenario we call it marginal utility of money. It simply tells us how will our utility change when there is 1 unit change in the constant of the constraint. Okay, what was the constant of the constraint? We were having 4x plus 6y is equal to 130. Okay, marginal utility of money simply tells us how will our utility change when there is change in the constant of the constraint. What is the constant of the constraint? This 130. And what is this? This is income. Okay, how will our utility change when there is 1 unit change in the income of the consumer? That will be the marginal utility of money. That means if income increases in this case by $1, okay, utility will increase by 3.1 utilities. Okay, so because we got the value of u, or rather the lambda, because we got the value of lambda is equal to 3, so this 3 simply tells us our utility will increase by 3 units if there is $1 increase in the income of the consumer. Okay, so it should get, we should ideally get the value as 3, but I am not sure why I am getting the value as 3.1. Okay, I hope I make myself clear here. Thank you.